Hello everyone and welcome to our next session. This is the beginning of the kind of last session of our text, our class. The big thing is we're going to first review the homework question as always. But once we're done that, we're going to look at three variable, three constraint problems. And the reason for that is because as we move into the final exam, you need a basis for this before you take the continuation of this course, managerial decision making, which some of you have taken, but should not have taken before this class because this is the prerequisite to that one. So hopefully everybody's okay. Hopefully there are no problems. And without further ado, let's begin. The Bluegrass Distillery produces custom blended whiskey. A particular blend consists of rye whiskey and bourbon whiskey. The company has received an order for a minimum of 400 gallons of the custom blend. The customer specified that the order must contain at least 40% rye and not more than 250 gallons of bourbon. The distillery can produce 500 gallons per week, regardless of the blend. The production manager wants to complete the order in 1 week. The blend is sold for $5 per gallon. The distillery's cost per gallon is $2 for rye and $1 for bourbon. What blend will satisfy all the requirements and minimize cost? A key point here is that not all of the information given to us in the question is relevant. That's the hiccup thrown at you today. So let's begin, and as always, the key is to go through and consider whether something is relevant to the question or not. In this situation, the first thing, as always, is the objective function. We are trying to minimize cost. To minimize costs, we have to know what our costs are. So, for example, in this situation, we have minimum Z equals 2x1, which is rye whiskey, plus 1x2, bourbon whiskey. Then we have to look at our constraints. And again, not all of this information is relevant. The company has received an order for a minimum of 400 gallons of a custom blend. So we know it's 400 gallons. So x1 plus x2, the amount of 1 and 2 must be greater than or equal to 400. That is important. So our first constraint is x1 plus x2 is greater than or equal to 400. Next, the customer specified that the order must contain at least 40% rye and not more than 250 gallons of bourbon. So 40% rye, 40% of 400 is 160, meaning x1 rye must be greater than or equal to 160. That's what we know so far. Also, we know x1 must be greater than or equal to 160. x2, which is bourbon, cannot be more than 250. So x2 must be less than or equal to 250. The distillery can produce 500 gallons per week. This is not relevant. We produce 400 gallons. So the 500 is less than, or 500 is more than that. It doesn't enter into the equation. Finally, the blend is sold for $5 a gallon. If we are focused on minimizing our costs, the actual profit or the amount of money we make isn't relevant. That's also not important. So in this situation, we have only three variables. x1 is greater than or equal to 160, which is our minimum amount of rye. x2 is less than or equal to 250, which is our maximum amount of bourbon. And x1 plus x2, the amount of rye plus bourbon, must be greater than or equal to 400, our order size. Once we have this information, we open our QM. We click on Module, we go to Linear Programming, and we open a new file. We'll call it our whiskey example. Constraints we have, as we saw, we have 3 constraints and 2 variables. We're attempting to minimize. So this is, as I said last time, this is from the last class, so we're still on a 2 variable problem, bourbon and whiskey. We click OK, and we see how very simplistic this chart is, and we have to fill in our relevant information now. First one, rye whiskey. Second, bourbon whiskey. Our costs for each are $2 and $1. First minimum constraint is maximum amount of rye. Our second constraint is, it was minimum amount of rye. Next is maximum amount of bourbon. And our third and final constraint is total order size. Now, one thing we're going to look here, minimum amount of rye. If it's a minimum, it has to be greater than or equal to the 160 we require. That's self-explanatory. If it's maximum, then this has to be less than or equal to 250. That's a key point because it's not always clear in real life how these interact with each other. So our minimum amount of rye is greater than or equal to 160. Our maximum amount of bourbon is less than or equal to 250. And the total of both must be greater than or equal to 400. Nope, not 4,000, 400. So if we've entered all of the information correctly, we should get the correct answer. What we see here, though, is it's pretty clear what the answer will be. Rye has to be more than 160. Bourbon has to be less than 250. 160 plus 250 is 410. We only need 400. So it could be a combination of 160, more than 160 plus less than 250. But we see that bourbon is cheap. So we want more bourbon, less rye. So the answer most likely is going to be 160, 240 for exactly 400. Let's check. I was correct. We have 160 gallons of rye, 240 gallons of bourbon, which will give us 400 total gallons and generate a profit of generate costs of $560. This is the key information available to us. This is our optimum choice. We should not include any more rye or any more bourbon. Only exactly these amounts. If we include any less, we won't have 400 gallons. If we include any more, then we will generate higher costs. So in total, this is our optimal solution. Let's try one more time in Excel. And again, I'll maximize or lengthen my columns. My rows, sorry. Now, what I'm going to do here is I'm going to go all over the place. When we are setting these problems up, I've generally kept the information here with available and our usage over here, our product that the computer will run permutations of down here, and our final goals. But what we'll see is that it doesn't matter where you do this information. What's important is how you indicate the information to solver. So let's begin. Rye, bourbon, cost $2, $1. Now what I'm going to do is we'll move over here. And again, it doesn't matter as long as we use solver effectively. So we have min rye, max bourbon, total order. We have 1 less than or greater than or less than or equal to 160. 1 greater than or equal to, this one is less than or equal to, this is greater than or equal to, and that's 250, and finally greater than or equal to 400. So as you can see, I've done all of this over here. Now it doesn't matter in any way as long as I enter my key points into solver. So I'll go here, products, rye, bourbon, and I'm ultimately worried about cost. Cost will do down here. This is much more difficult to follow, much less clear, but it's to illustrate that the actual spaces don't matter. So now that we have all of this, we can enter our formula. So our usage of rye is equal to this times the amount of rye. Here we have 1 times our amount of bourbon. And our total order is this rye times rye plus bourbon times bourbon. Our total cost formula is very simple. Rye times amount of rye plus cost of bourbon times amount of bourbon. And very simply, I'll come up here. We'll go to data, solver. This is where I have to be a little more careful. So our ultimate cost is down here in D20. I'm trying to minimize. The cells I run permutations of are right here. They do not have to be beside each other. I can click on different cells all over the spreadsheet, but I am keeping them beside each other. Click on Simplex LP, and we'll add our constraints in. The first one, our usage of rye has to be greater than or equal to 160 J10. We add that. Our usage of bourbon must be greater than or equal to 200 J11, 250. And finally, our last group, H12 must be greater than or equal to 400 or J12. If everything's been entered correctly, it doesn't matter where it's located on the spreadsheet. It should solve properly. All constraints and optimality conditions are satisfied. We hit OK. For some reason, and let me double check right now. I see right away where the problem is. Our usage was 410, so we have to go in to Data, Solver. Let's change one of our constraints, the last one, H12 to J12. We're going to go H12, which is 410, must be greater than or equal to 400, J12. So we see that's correct, so we click OK. But we're going to see our cost, D20 is 570. We want to minimize. And for some reason, it's not minimizing. We know if we do less than or equal to 250, so when we open our solver, we see the problem is up here. When I entered the information, you can see if we look at all of our constraints are greater than or equal to. We have to make the second one the second constraint must be less than or equal to. We hit solve, and we see that the solutions correct themselves, and we're at 560. So we'll close this window, and we'll move on to our next question. So let's look at our next question. Metro Food Services Company delivers fresh sandwiches each morning to vending machines throughout the city. The company makes 3 kinds of sandwiches: ham and cheese, bologna, and chicken salad. A ham and cheese sandwich requires 0.45 minutes to assemble. A bologna sandwich requires 0.41 minutes, and a chicken salad sandwich requires 0.50 minutes to make. The company has 960 minutes available each night for sandwich assembly. Vending machine capacity is available for 2,000 sandwiches a day. The profit for a ham and cheese sandwich is 0.35. The profit for a bologna is 0.42, and the profit for a chicken sandwich is 0.37. The company knows from past sales records that its customers buy as many ham and cheese sandwiches as the other 2 sandwiches combined, if not more so. However, customers need a variety of sandwiches, so the company stocks at least 200 of each of them. How can they max their profit? So this one is going to be relatively straightforward, but there are quite a few constraints to deal with. So let's look at that together. The first one, objective function, as always. We see from the last sentence, how can they max their profit? So max Z equals, and then we look for how much profit they make per sandwich. Max Z equals 0.35x1 plus 0.42x2 plus 0.37x3. For all of this information, we are very, very set now. We have to start looking at our constraints. The first one, how much time to assemble? We have 0.45 minutes. I'm going to convert to seconds just for simplicity's sake. So 0.45 minutes is 27 seconds. Bologna sandwich is 0.41, which is 24.6. And finally, 0.50 is 30. The only thing I have to do here is convert 960 minutes to 57,600 seconds. That's our first constraint. Our second constraint, capacity is 2,000 sandwiches a day. The profit for a ham cheese, so if If capacity is 2,000, that means our total of all sandwiches, so x1 plus x2 plus x3, must be less than or equal to 2,000. Finally, the company knows that they buy as many ham and cheese as the other two combined, if not more so. So this will be x1 is greater than or equal to x2 plus x3. But we can't calculate, we can't enter that in the computer effectively. So we're going to change it to x1 minus x2 minus x3 is greater than or equal to 0. Finally, company wants to stock at least 200 of each sandwich. So we have x1 is greater than or equal to 200, x2 is greater than or equal to 200, x3 is greater than or equal to 200. We click here, and we have all 6 constraints aligned in this manner. So once this is done, very simply, we're going to go into, because QM is relatively easy and I want to give you time for the homework problems, I'm going to solve only in Excel. So let's open up an Excel file. Click on a blank workbook. Lengthen all of our columns. And we're going to minimize each of these because I want to be able to see when I'm typing. So we'll call this our sandwich example. I'm going to go back to a more standard format now, but I am going to go relatively quickly because this should be very clear now. We have 3 sandwiches, so products, ham, bologna, chicken. We're trying to maximize profit of 0.35, 0.42, 0.37. And down here, very simply, our first one is time available, second, space available, third, ratio, min ham, min bologna, min chicken. These will be our 6 constraints. So time is 27, 24.6, 30. It must be less than or equal to the 57,600 seconds we have available. Oh. Space is 1, 1, and 1. Must be less than or equal to the 2,000 spaces we have available. Ratio is 1 minus 1 minus 1. Must be greater than or equal to 0. Minimum ham, 1, greater than or equal to 200. Bologna, 1 is greater than or equal to 200. 1 is greater than or equal to 200. Now, we come down here. We relist our products. And we can see that once we're very clear on this, even Excel takes very little time. So ham, bologna, chicken. Max profit. We enter our profit formula, which is the profit per ham times the amount of ham plus the profit per bologna times the amount of bologna plus the profit per chicken times the amount of chicken. We do something similar here. Oh, something went wrong. My formula must have been mistaken. So equals again. Each of these is much simpler. Times it by the equivalent. And we've successfully completed the problem, except for the solver situation. So we click on data. We go into solver. Our ultimate goal is found in B19. We're trying to maximize by changing the cells B15, 16, and 17. 3 variables, 3 cells. Simplex LP as always. And we add our 6 constraints. The first one must be less than or equal to 57.6. Less than or equal to 2,000. Greater than or equal to 0, greater than or equal to 200, greater than or equal to 200, and finally greater than or equal to 200. So we have all 6 of our constraints listed here. Once all of this information has been correctly entered, we hit solve. We see that solver found a solution. All constraints and optimality conditions are satisfied. So we are going to make 1,000 ham sandwiches, 800 chicken, 200 bologna. That's a total of 2,000, which is enough space. We also know that if we see here, that's 52,680 seconds. We have 57,000. We have enough time. We know from the ratio that we have to eat at least as many ham as bologna and chicken together. Bologna and chicken together are 1,000, so ham is at least 1,000. And finally, there's 200 in each of each type of sandwich. So this is correct also. If we follow this system, we're going to generate a profit of $760, which for us is our optimal choice. Thank you everybody for watching. Hopefully there are no problems. I'm going to leave you with the homework question now. If you have questions, please ask me and I'll do my best to help you through Kakao. The homework problem does not have to be submitted, but you have to solve it and answer the questions before 2 o'clock, before your class ends at 3, or before your class ends. Thank you again for watching. Here is your homework problem. All right, everyone. Thanks again for watching. If you have any questions, please let me know. I'm always available to contact through Kakao, and hopefully everything went fine. But if not, please let me know. I'll see you in the next session.